Welcome to the Math Building. I'm Gregory Carlson. Let's talk about the constant multiple rule, which we're going to look at a series of rules that allow us to manipulate derivatives. And what the constant multiple rule says is if I am taking the derivative of a function that's of the form a constant number times a function. So if you're taking the derivative of a function that has some constant number, and c is a real number, by the way, then what I can do is I can kind of factor out the constant number like this. So I can factor out that constant number and kind of slip my derivative inside of the constant number. And then you take the derivative of the function, and so you just get the following. So that's kind of nice. So if you have a number that's just being multiplied by a function, you can factor off that number and then take the derivative and then multiply it back on with the distributive property. So let's look at the proof of that. We're going to look at assuming again that our function is of the form c times f of x. We're going to use the definition of the derivative. So we see the limit as h goes to 0 of, first we do f of x plus h. And since there are no x's involved in my constant number, remember that's just a number like 3 or 10.2, I can just write f of x plus h as c times f of x plus h. And then I subtract my function, I subtract it, which is c times f of x, all over h. So that's the start of the proof. You can see that I have a function with a number being multiplied by it. And you can see that I can factor out that number. So let's do that. We have the limit as h approaches 0 of c times f of x plus h minus f of x on the top and h on the bottom. And as you remember from a previous video, we can go ahead and factor that c outside of the limit as well. So that is equal to c times the limit as h goes to 0 of f of x plus h minus f of x all over h. And now you can see that this right here is just the definition of the limit. The definition of the derivative. And so that's just equal to c times f prime of x. And that completes the proof, so QED. And so we're going to use this trick in a few videos. You'll see how it works with an example. So just remember that if you have here's the statement, if you have a number times in your function, you can factor out the c and kind of slip in the derivative and derive the function with that number on the outside. Next, we'll look at the addition rule.